computer. So. How do I get the? Okay, that's why I can't access this. I can't access this data file on that computer when it's set to this computer. So, well, how do I want to do this?
Good afternoon, Matt. Can you hear me?
Yeah, his phone's muted.
I think you're muted.
Can you hear me now?
Yep, I can hear you now.
Want to go ahead and get started, or are we still waiting on some people to join?
I don't know who all's going to be joining. We've got quite a few on today, so I would say let's just go ahead and get started. And welcome everybody to the Exact Metrology Polyworks, the third session in 4 that we have scheduled, and this will be focused on creating features based on scan data.
And everybody can see my screen right now, the Polyworks screen?
We can.
Yeah.
So my name's Matthew Martin from Exact Metrology, and I'll kind of do a little bit of overview of stuff that Phil and Mike have probably hit on in the past 2, just to kind of get us to creating the features. So what I'm going to do is open a blank IM inspect, and then I'll bring in the CAD file. I'll bring in the STL. We'll do an alignment, best fit alignment, and a datum alignment, and then we can start creating some features, after doing that datum alignment. And I can kind of show you some different tips and tricks on that, and then just kind of, I guess, shout out questions if you got them as we go along. So I'm more of a right-click kind of guy in Polyworks. So to bring the CAD file, I'm just going to right-click on Reference, Import CAD file. And it's going to be a Honda cover, engine cover. So we actually modeled this part up as design intent. This is the design intent model so that we can do this webinar. Models in there. We'll go ahead and bring in the STL scan data. We scanned it with our GE CT scanner, and Josh Straden did that for me. Go ahead and bring in that. And we're in inches down here in the lower right-hand corner. It's in inches. You can flip it to whatever units of measurement you would like. So I'm gonna keep it in inches. So right now the gray showing is your CAD. That green, nasty green color is the scan data from the CT. So I will run an alignment. I'll come up here to the alignment tab, which is these three little planes. I'll come down here to the best fit data to reference objects. And I'll go through here and kind of set the settings before I run it. I like doing the pre-alignment with point pairs, just because I like controlling the initial 3 points that it picks. And then this max distance of 1 inch is way too big. We'll go down to like 30,000. You really want on your best fit, just go over a few things. You really want that a little bit bigger than your max air of your part when you're running a best fit. So you kind of want it a little bit on the higher side. And that's all set. And then we will run this. So little brief overview of kind of what we did the last one. Go ahead and pick your 3 points. And then right click ends it, and now it's going to run through this algorithm again, running that best fit. Close out that window, and now in the tree view, it's got the best fit to reference with the little green check. Again, means that it's programmable and ready to go if you were to change out parts. I'll go ahead and apply the color map. Max distance of 1/2 inch, like way too big. Point 1 on the color map. And now we'll go in here, and I'm going to go ahead and adjust this scale. Right now, it's everything green is plus minus 1 thou and a half. We'll probably put it at 5 thousandths.
Oh, I thought it was fun for a second. I thought that was fun for a second. I just looked at Carol and Mike was looking for it.
And we'll put the max and min distances to like 20,000 or 20 thousandths. And I'll only do 5 colors in between them. That kind of makes that a little bit more realistic of what a part's going to do. So now I'm going to turn the hide and show color map again on the right hand side. So I'll turn that off. And then I'm also, if you have 3-button mouse, you can middle mouse click the STL in your tree view, and that's hide and show. So I'm going to hide the STL so that I can just start creating features on the CAD to do the datum alignment. So what I'm going to do is create a plane for datum A, and then I'm going to go ahead and create a vector for datum B, running through this post, and a clocking point for datum C. So what I'll do is come in here and create plane feature. The method, or I'll put the datum, turn on the datum feature label A, so that it gives it the automatic label. The method's going to be pick on CAD model, and right now it's single surface or multi-surface. I'll just keep single surface since all of that is one surface. The reason you would do multi-surface is if it kind of like is broken up in the CAD, when it comes in, or the CAD modeler broke up that surface that's actually datum A or datum B or whatever feature you're picking. I'll roll the mouse over it and see how it highlights it kind of in white outline with green filled in. Click it, and then it applies the, now we have a plane there. I'll go ahead and change this to cylinder. And we'll zoom in. So this is the kind of the pretty good example of basically telling you it's not a cylinder, because it's not being the green color with the white outline. So I'm going to go ahead and have to change this to a cone. And now it's telling me, yes, that is a cone feature that was used to create this part in CAD. So I'll go ahead and change this to B on the datum label. Come back in here, apply that. Now we have B. Now we'll go back up to the clocking pin for C. And what we'll do is I'll create a cylinder. Just a normal cylinder was called cylinder 1 by clicking that. So now we need, basically want this, you know, intersection of the cylinder vector to the datum plane A. So what you'll want to do is select datum plane A, and then the feature it's intersecting. Have those selected in your tree view. Go up to the whatever feature you want to create. We're going to create a point feature. We're going to change the method from intersection, and the sub method of this one is going to be a plane and a cylinder. You have multiple sub methods in there to create, you know, points or create lines or create whatever you need. We'll go ahead and apply the C datum label and click create. So now we have the 4 features used to create the 3 datums. What I usually do at this point, when I usually lay out the datum scheme first, and then I'll go back into the tree view and select all the features used to create the datum scheme. And you can right click on all of them and go to edit group right here. And that puts them all in a little group, and then I usually right click on the group and go down here to object group, rename. Now I'm going to name this alignment features. It just makes it look cleaner for people looking at your workspace. It makes it look cleaner for anybody picking up on the part. If you haven't inspected a part for a while and you come back, you can easily look in the operator prior to you or whoever programmed the part, and you can see what's in that group real easy. So now that it's kind of all cleaned up and ready to go, we can start extracting these features, these ABC features, from the scan data to create the datum alignment. So what I typically do, so I usually hide the step file, again with the middle mouse. I'll turn on the STL, right click and extract measured. Now with the little green check mark, it says it extracted it, it's ready to go. One thing you would want to do as you look at your features in extraction is you're going to want to make sure that that feature is extracted properly. So if you highlight the feature and say Control M is going to highlight every point on that scan data in red that you used to create your plane. So you can go around. You want to make sure that there's no points, like you don't have a distance set that all of a sudden it's picking points down on a different elevation of where the plane should be. Or it's not picking them, say it's not picking them down here in the radius or something. and then Control N is deselect. So we'll do that on the code datum B. We'll extract the measured. And then again, make sure it's selected, Control M. Control M. And now we can kind of go back and look to see what point it used to create that feature. Now, if for some reason you don't like it or it starts selecting points you don't want, what you do at this point is you deselect those points, and then you want to open the properties of the feature, then that you can start tweaking. So we basically double click the feature, and you're going to have two, most times you're going to have two tabs. Feature tab showing you, potentially if you have a datum label applied to it, a couple other little properties if you want, custom properties. But the main tab is going to be the measurement tab. This is going to show you how the feature was created. We extracted it. You can CNC probe it. You can probe it or use nominal primitive. So we extracted it. We did a surface extraction. And then we did the fit zone is a default fit zone of my settings. You can come in here and play with this fit zone. You can make it, half an inch. And every time I adjust this number in the background, because it's basically you're writing the program, it's readjusting that cylinder. So now, because I've set this max distance to an inch, that's where it's making the cone. So if you start readjusting, it's constantly updating, searching those points. So really, because this is a pretty accurate part, you could probably do 30 thousandths. So if we do 30 thousandths, Control M, now again you can see the points that it's looking at. So really the main ones that we have to play with is if the max distance needs to be changed, or if the if you turn a constraining plane on, if you want to constrain it to a certain axis. The other one is the boundary exclusion distance. You really have to mess with this one when it's small features. When it's large features like this, it really doesn't really affect the extraction. But if it's a small feature, which unfortunately we don't have any small features, like medical parts, very small like circuit board parts and stuff like that, this number needs to be really low, almost 1 thou or 2. Not almost 20 thou like it's default set to. So depending on your part, 20 thousandths is fine for a machine part. On medical stuff, I'd definitely make that smaller, because what this does is basically deleting points from the selection to get a better sampling. And on small features, it basically deletes every point, so then it can't fit the actual feature. Okay. And then we'll go ahead and fit this cylinder. Now, because the cylinder was used in correlation with datum plane A to make the point for C, it has this little relationship chain, which is in Polyworks called a dependency. So it's dependent upon these features being extracted. As soon as I extract cylinder 1, it'll automatically make datum point C. And now we have the datum C nominal and measured point ready to go. So we'll go ahead and check that extraction. Make sure there's no points kind of being pulled from anywhere that I don't particularly care for. Looks all good. What I usually do too, just to make my workspace look cleaner as well, is I turn off all the callouts that are on by default. So in order to do that, the easiest way is to hit, there's a little triangle menu button in the tree view. You can hit that, go down here to your controls and open that up. So now when you go down to like Datum Cone B, you can see the angles turned on and it's showing up in your 3D space. You can hit the Add Remove Dimensional Controls button and then just uncheck it. And I'll do that for the cylinder to take the diameter off. And then I'll select the datum point and turn off the XYZ of that datum point. And again, this is just, you know, personal preference stuff that I kind of do when I'm setting up a first article inspection. And if you hold Alt, you can move these anywhere you want. So now, since we have all those extracted, I can now run the datum alignment. Come down here to the very bottom, the datum reference frame alignment. We'll go ahead and do a create. Again, you can create your ABC alignment any way you want it. We could do CBA, BCA. We'll just do an ABC. As soon as you create it, it's up here as one you can select. And we'll click Align. It automatically, that little bar that went off pretty quickly, it automatically updated the deviation map to show the deviation now in the datum alignment. So now if we right click and say activate on the best fit, because now you have a datum reference frame alignment, ABC, and the best fit, activate. There's your best fit. Activate the ABC again. I can definitely see some differences in the color map for sure. So now we'll create some more features on this thing and start pulling some dimensionals. Go ahead and turn off the color map. Turn off the STL. Turn on the design intent. And what I want to do next is the ability to create a pattern on these four locator threaded bolts. I believe they're threaded in the scan data. Yes, they are. So what I will do is I will create 4 cylinders. Go ahead and hit the Create Cylinder button. Again, the method's pick on CAD. It's the easiest method you'll do in Polyworks is pick on CAD when you have a nice CAD file. So you can just go around and basically 1 or 2 clicks and get all the stuff you need. Now that I have these cylinders created, you can create a pattern by selecting them all in the tree view, hitting your create pattern feature. You know, and most of the time a pattern is is another datum. I'll just name it datum D for. And now it automatically ropes all of that, all of the 4 cylinders into that pattern. So you can apply this. Basically, what the pattern gives you the ability is to apply, like a lot of times you'll see a pattern of bolt holes that have a true position back to A applied, or some type of call out. Usually it's a GD&T call out in the pattern. So now these will be a little bit different extracting because they are on threaded areas. So we'll just start with I don't know if you guys can kind of see that the CT data got all, there's little threads in there. So we would go ahead and just start extracting. This one I definitely want to check because of the threads. So there's definitely a difference in there, but so what you can do is you can, this cylinder 2, you can hit this plus sign and actually open up and see if it's, see the nominal and measured cylinders by themselves. So I'm going to go ahead and middle mouse click on that nominal to hide it. And now I can really look to see how that cylinder 2 measured data is fitting just visually. And then I'll turn it off again so that I can do the Control M to really look at how it's fitting. And I particularly don't like doing like a best fit on a threaded hole. I'd rather do a min fit. So what I'll do is we'll go into the features of the cylinder, go into the measurement tab, and I will change the fit settings. So down here below the boundary exclusion distance that we were going over a little bit before is this fit tab. You can now open it up and you got fit types. So now you have best fit, min fit, max fit, ability to change it. I really like doing the min fit on the threaded hole, so I'll go ahead and change it. It's in red telling me you've made a change, but you haven't applied it yet. So you can either hit enter or you can hit the apply button down here. Now it's applied, and now we've made that change. And now it's fitting, just barely hitting those grooves of the screw hole. Threads. So now I know that's a pretty good setting. I'll go ahead and select the next 3 cylinders all at once. I'll right click and go to properties on those. Go to measurement. And because I haven't extracted any of these, it's asking me, the measurement is now undefined on the other 3 that I haven't done. So I'll go and change this to extract. And then I'll also come down here and change that to min. Go ahead and get that all set up. So now when I extract these, they will all be min fit cylinders. So you can select them all at one time and just hit extract. And we'll go ahead and turn off the nominal cylinders and just make sure that those cylinders are fitting in there pretty nicely. Yep, this will look pretty good. So now we have our 4 cylinders. Got the pattern turned on as well. But now I want to create a couple 4 circles around this thing as well. So I'm going to use, what I'm going to end up doing is creating a plane, a multi-surface plane, and then go ahead and create the circles from that. So we'll go ahead and turn off all that, turn off the STL. We'll turn back on our CAD cover. I'm going to fit a plane, pick a plane. So right now I have it on single surface. But really I want to make sure I get this surface as well over here. So I'm going to change the sub method to multi-surface. So you'll click once and now I can add this surface over here. So now it's got both surfaces selected. You click it, left click again, and then right click to end the selection. So now it's got that entire surface being used as plane 1. We'll go ahead and extract that plane as well. Do a quick check of the plane. Make sure those points are not being taken down in those holes, which would be my biggest concern. Okay. Now what we'll do is we'll create the 4 circles from the intersection of the plane and cylinder. So I'll select all the cylinders, select the plane in the tree view, go back up to the circle feature. We'll change the method to from intersection, plane and cylinders, click create. Now kind of a tip is, if for some reason it says it cannot create a circle from the cylinder or from the intersection of the cylinder and plane or cone and plane, what it's really telling you is it's not a true circle from that intersection. So if you just change it to create a slot or an ellipse, is what Polyworks calls it, it'll create an ellipse. It's just not a perfect circle, and that's kind of an error sometimes that pops up in Polyworks, more or less telling you that, hey, your intersection point is not perfect, so you therefore need to create it as an ellipse and not a circle. So now we have those 4 circles created that, again, may need to be, measurements may need to be pulled off of the circles, or just getting the XYZ points of that exact location of the top of that threaded hole compared to the plane surface. Now what I can show you is say we don't have any, say you didn't have any CAD and you had to actually still take measurements. So we'll go on the back side for this. Say you needed to define this plane and this plane because you wanted to take an overall height measurement. So what you would do is, if you didn't have the ability to have CAD for it, which makes it easier because we pick on CAD and then extract, you would actually have to go in here and create the plane feature, change the method to fit, and at this point you would want to set up all your settings. So do you want a best fit plane, do you want a mid plane, max plane? Same thing with cylinders or cones. The max angle, do you want that on? Is usually a yes, because you don't want it to be backwards facing. Do you want reject outliers is on by default, and that's pretty good, 5% a point. The subsampling step, sometimes if you have a huge surface that you're trying to fit a feature, you might want to turn that on to kind of sample it down a little bit. So once you get all your settings, the right type of fit, you'll come in here and hit the space bar. That turns on the selection ability of your little ring. Now you can come in here and hit your left mouse key and start basically just doing a slide selection. And just basically painting the surface where you want that plane to fit and what points you want that plane to use on the fit. So once you've got all your points selected, what you want to use, you just hit create. And now your feature is created. What you'll notice when you're doing this is it's no longer like a trimmed surface. that you can use. Now it's kind of just an oddball looking features. So we'll go ahead and do it again down here. So it's a lot more time consuming if you don't have CAD to take measurements. It's something on the service side for Exact that, you know, if we have CAD, we know it's going to be quicker doing a first article. If the client doesn't have the CAD model, we have to take that into consideration when doing these, because it's a lot more man hours spent of the guys going in there and selecting the features manually and doing this kind of work and building. Whereas if we have the CAD model, it's an easy click and you can kind of get your settings set. So I got a pretty good sampling on that surface. We'll go ahead and just do a min fit. Create. Now that plane is down here. And you still doing the same type of application. You can go back in and do the Control M and look at the points that were used to create that feature. So that's still relevant, and you're able to use that. One thing to take in mind, you know, depending on the technology you're using, the method, you know, we did pick on CAD, we did fit. You can do anchor, and anchor basically is anchoring 3 points. So anchoring, you would come back in here and say, I want this point, and this point, and it's going to anchor it's going to build a plane based off those 3 points. You can also do pick one on the surface, pick one on the reference boundary. You know, those are options if you need them. The other big option is probing. If you have a roamer arm, you can change this to probing, plug in your roamer arm, and basically start probing all kinds of points to create a plane, just like a traditional CMM. The numeric, the empty feature is used for when you need to kind of do a little bit of programming. We actually had to use it today for a part when we were basically creating a probe, simulating a probe type of thing, where we had to create a little sphere. And again, from objects is the other one, and that's going to be sub method of basically how am I going to create that plane. Is it going to be from the center points of circles? Is it going to be from a point in a line orientation? So there's, I bet you 20 to 30 ways per feature to get created on them. So if you say from objects, just kind of we can do that one real quick. If I take these our 4 circles, and they're all moved around, these 4 circles, what we'll do is we'll create 4 points, and then I can use those points to create a plane on the feature. So from objects, create points from objects, circle centers, create. And we'll use those same points to create a plane. So really, Polyworks gives you the ability to build features off of features. You just have to go about it in the right kind of steps and knowing the right features and what they are. Some issues you'll run into is with CAD files. You'll think that the feature should be a cylinder and it wants to fit a cone. And like I said before, sometimes you'll think the feature is a circle and it will want to fit a slot. And that's just the way the CAD model is. That's not an issue with the translator in Polyworks. It's just how the CAD model was built in the CAD package of choice. There's a couple other special features that they've introduced here lately. One of them being, we'll pick this surface here, is Create Surface feature. This is mainly used for surface profile GD&T callouts. And they only give you one option three options, but one main option is with the CAD model, which is reference elements. So what it's basically asking you to do is select the reference element that you want this feature to be. So if you hit the middle mouse button again, you can select all the features you want to be a surface feature. So now we want basically those 5 features to be a surface feature. And you'll hit create. And now this one, I'm going to hide the CAD model. That is one surface feature. Now you can apply basically an overall surface tolerance to it. The surface profile call out of maybe this has a 1.5 thou surface profile tolerance on it. And this is how you would apply it just to that surface. We'll go ahead and extract that surface from the points. So same thing, right click, extract measured, hide this. And if you notice, you can't really truly see, there's no plus sign by the surface to show you the measured. So what you have to do is this one, you really have to look at the points and kind of see exactly where it's pulling from. That looks like it pulled it pretty good. It's a little tight. It's getting a little close to that radius down there, but we'll leave it go for now. Because you can't look at the features compared to each other visually, you definitely have to look at those the points and how it's getting pulled. And that one was specifically introduced for surface profile, I believe, at the time. The other one is the new slab feature. It's called Create Slab feature, and you have to create 2 planes. The big, let's see if we even have, I even have the ability to create a slab. They have to be parallel planes to each other. I bet you I do. So if I have, I'm going to go ahead and do the pick on CAD again. Single surface. I'll put one there. Go ahead and put one on the other side. The planes must be perpendicular to each other and parallel. Go ahead and select. We'll select those 2 planes. Create slab feature. Since I had them selected in the tree view, it automatically puts them as plane 1 and plane 2. Usually a slab feature, it will have a datum on it. That's why it's kind of introduced, because it's on a lot of drawings. That's what they're used for. Should see if it'll let me. Yep, went ahead and created it. So now it's in there. It's kind of a different looking feature than the plane. Go ahead, let me hide. So I can kind of see the slab feature is the dotted line. The planes used to create the slab are the checkerboard looking. Go ahead and extract. Yeah, that's kind of a better view. Got the checkerboard here, the dotted line here. That tells me that's the slab plane. That's just more for visual. For Polyworks is visual. that. Does anybody have any questions so far? I know it's already 4:15. The other kind of features, just to kind of show you if they're 3D, 2D, the ones with these little plus signs have they're kind of 2D features. The 3D features are kind of the ones that are more rendered look on the Polyworks. The arc feature is a newer feature as well. You have to do an arc on a cross section. So we can go ahead and throw as the kind of the last feature to show you today is the arc. Go ahead and I'll just create a cross section somewhere. That's like a pretty good one. So create cross sections. Let's go up into the create standard cross section. Right now I'm in the X individual mode. Preview kind of shows me where cross section is going to be taken, and I'll just confirm it. So now I have a cross section that's now nominal and measured. Again, the colors represent the CAD to the STL. So it puts it down here in the cross section, underneath the cross sections. Hit the plus sign. Now you got your nominal and measured cross section. I'm going to go ahead and middle mouse click the measured engine casing. And now basically I'm just looking at the gray of the CAD. Come up here and create arc feature. It automatically selects cross section 1 because that is kind of the only cross section I have. And I'll see if I could pick on CAD. So pick on CAD, it's saying there's a perfect arc right there. Go ahead and create that one. Create one on this side as well. So now I have 2 arcs created. What's really nice about Polyworks is it kind of organizes it. It shows you that, yes, you have 2 arcs created in your tree view, but they're also tied to cross section 1, which is basically in the X direction at the 0 position. So it kind of organizes your tree view really well. All right, go ahead and turn the measured back on, then we'll right click and extract the measured. This is, you'll end up getting this message saying it can't extract. No measured data points could be found in the current extraction parameters. So we'll go in here and investigate why this is not wanting to extract. So now we want to double click arc 1, go into basically double clicking is getting into the properties. Extract from cross section, distance. I'm going to change this boundary exclusion distance down to like 2 thousandths. And I think I'm going to take reject outliers off as well. Set that, and then maybe turn off this distance to see if I can't get it to find the exact location of that. That's 0. Oh, there's also a setting in here, extract from best fit cross section. So if you wanted to view the cross section in the best fit, like how it looks in the best fit, you could double click your cross section 1 in the tree view. believe, on the cross-section tab, there's a best fit. If I check that and hit enter, now it's showing me the best fit look of how that's getting, what basically the range of that cross-section is. It says max distance, I changed down to 20 thousandths, and it was able to now fit an arc there. We'll do the same on the other side. This one I'm assuming is going to air out as well. Yep, make sure it's the same air. Yes, no data points can be found using the current extraction parameters. So again, you're going to want to investigate. Double click, gets you in the properties, go to the measure tab. You now know, if you had a series of arcs, you would probably want to set this up going forward, selecting them all, because you kind of know the settings now. Kind of take the boundary exclusion down to super small. Turn off the reject outliers, make this a little bit smaller to 20,000. So now it extracted. You know it extracted, you know how it's fitting. You got the cross section in the best fit, so you can kind of see what the software is doing in the background to fit that arc. So now we have those extracted as well. But just remember, the arcs have to be on cross sections. You can't just randomly pick on this CAD file. I want an arc at wherever you're basically anchoring it. The software will not allow it. You have to take a cross section, cuts through where you want it. So that's basically all I got. I left a little time, 10 minutes or so, for questions if there's anything anybody wants to ask or review. That's all I have, unless somebody has a question or anything. So.
All right, well, if nobody has any questions, thanks a lot for presenting.
All right, thank you.
Thank you.